Okay, so we're going to have to apply Kirchhoff's rule in here. All right. First of all, we have to know that the long terminal is the positive one and the short one is the negative one. The same applies for this battery. Here we have two batteries that are going to be in series with each other, and the current has to leave the long terminal. Now, of course, you're thinking, I have two long terminals, so current has to leave both. Now, since the 12 volts is larger than the 4 volts, what's going to happen is that the current of the 12 volts will overcome the current of the 4 volts. So we're going to go ahead, we're going to erase this one. We're going to just keep the current of the 12 volt, which is now going to be traveling essentially counterclockwise. So our current will be traveling counterclockwise. I always suggest that you choose the direction of travel to be also counterclockwise. So right now we have the current. Now the question is, why would I pick the travel to be also counterclockwise? I always recommend that you pick the travel to be the same direction as the current to make your life easier. Of course, you could have chosen clockwise for travel, but in my opinion, that will make your job harder. So always pick the travel the same direction as the current. Now, let me refer to current with the color blue, and let me refer to the travel with the color of red. So travel is going to be counterclockwise and current will also be counterclockwise. Now, of course, we should show you the signs. The signs are important of the Kirchhoff's rule. Let me pull that up. So these are the signs. If I were you, I would recommend stopping the video right now and taking a screenshot of these because they're going to be ultimately very helpful for the duration of this video. Now we are requested to do two things: to find the current in the circuit and to also find the voltage between point A and point B. We'll start with number one, which is to find the current in the circuit. Now what's going to happen is the current will be traveling in the battery from the minus to the plus, right? And so that would be a plus for the voltage. So we're going to go ahead and we're going to write the equation to be plus 12. Next, the current will go through the resistor, the 2 ohm, in the same direction of the traveling, which would mean that if they go in the same direction, the current and the traveling, we're going to have to put a minus on that resistor. So we're going to have to put a minus I times 2. So IR, I times 2 for the R. And the same is going to apply for the next resistor, so I times 3. And the same applies for the next resistor, so I times 4. Next up, current's going to be going through this battery from the plus to the minus. So as the current goes in the battery from plus to the minus, we're going to have to put a minus on the voltage, which means that 4 volt will now be minus 4. Next, current will go through this 7 ohm resistor, and that's going to be minus I times 7. And of course, the whole thing has to end up in a 0. The summation has to be a 0 because if you're starting at point B and returning to point B, the summation of the voltage has to be 0. Now it's time to do some math. So we're going to have 12 minus 2i with 3i with 4i with 7i is going to be 16i. And of course, there's this minus 4 here. Let's not forget about that one. Minus 4, the whole thing is equal 0. So 8 minus 16i is equal 0. 8 is equal to 16i. Therefore, I is equal to 8 over 16, which means 1 over 2 ampere. So now if we're able to find the current in the circuit, that was the first requirement. And the second requirement is to find the voltage between point B and point A. Okay? So to find the voltage between point B and point A, we have to look at the voltage and the 12 volt, the battery, and the 2 ohm resistor, and the 3 ohm resistor. We have to combine all of them, right? Okay. The current, which is in blue, is going from point B, and the travel, which is red, is going the same direction. And if you recall the signs, this would mean that if the current goes through the battery from negative to positive, that'd be a plus voltage. So you're going to have to write a plus 12. But as the current goes through the resistor in the same direction of the traveling, we're going to have to put a minus on that. We're going to have to do minus I times 2, and the same goes for the other resistor, which is minus I times 3, right? Now the I was already found to be half in the previous section, if you recall. It's here, right? We already found it to be half. So I'll go ahead and replace the I with a half. So half and half. And you will get 12 minus 1 minus 1.5. You get 9.5 volt. This would be VAB. It would be 9.5 volt.